Homework 5, problem 6, find the magnetic field B in the center of a circular hoop carrying current I. Now I messed up on asking this problem. It asked definitely in the center of this hoop. What I really wanted to ask is along the axis. So at some point, a distance d up along the axis of this hoop. So if we call the radius of this hoop A and that distance d, find the magnetic field there. That's what I wanted to ask. So what I'm going to do is I'm going to solve this problem, and then I'm just going to set d equals 0 to find the solution that for the actual problem that I do ask. In order to find this, we're of course going to use the Biot-Savart law. Biot-Savart is magnetic field should be equal to mu naught I over 4 pi times the path integral dl cross script r hat over script r squared. For us, the current element, right, will be some current element there, and so I can write out what this dl would be. This dl is going to be equal to a d phi hat, right? And the r prime is the distance to that current element, so r prime is of course going to be simply a s hat, and r is the distance to the point of interest, so in that case that's this point up here, and so this is going to be d z hat. Using these two and the definition that script r is equal to r minus r prime, script r, which is that vector there, this is script r, right, is simply the, excuse me as I think this through, is minus a s hat plus d z hat. Okay. Now, from the symmetry of this problem, I know that the magnetic field will have to point straight up, because the magnetic field from this point will point a little bit this way. The magnetic field from the point diametrically opposite will point in the little opposite, and when you add the two, right, when you add the two, you're going to get a resultant that's only in the up direction. And so I'm not even going to bother calculating the other parts, and specifically, if you look at my dl cross r vector, which is what I'm going to need up here, because this script r hat over script r squared, of course, can be written as script r over script r cubed. This script r vector, the phi hat cross z hat will not be in the z hat direction. The phi hat cross s hat will, and so we're going to use that to determine our problem. And the phi hat cross s hat is actually in the minus z hat direction. So going through and writing this out, this b as a function of r is going to be equal to mu naught I over 4 pi, and then integral from 0 to 2 pi d phi. That's that d phi. I'm going to get an a here and an a here, so an a times a minus a, and then I'm going to have a phi hat cross an s hat, which will give me a minus z hat, all over this thing is going to be what, a squared plus d squared, so a squared plus d squared to the 3 halves power. Okay. Notice that all of this is independent of phi, so I'm just going to get a 2 pi from here, and so that my resulting magnetic field, B of r, is mu naught I over 2 a squared over a squared plus d squared to the 3 halves. Now, this is kind of the general solution that I wanted to ask about, but it's not the one I asked about. For the actual problem, we're going to let let d equal to 0, and that's going to give that's going to give that this is mu naught I over 2a, because we're going to get a squared on top and a cubed on bottom. There we go.